I appreciate so much for listening to this video about a new programming paradigm, grade 3. This is lecture 3. Today we'll make the second comparison. It's called concurrency model. I think for any distributed system, concurrency is the most important programming issue. Since distributed system is concurrency should be run in a concurrent manner in nature. So every distributed system should provide some concurrency support. I think if no concurrency mechanism, it's impossible. It's not that means the distributed system does not exist, right? So for every programming paradigm, if it claims itself to be a distribute technique, it should have a proper support for concurrency programming. So let's take a look the first some other existing ones. Let's take a look what about their concurrency programming model. ICA is I have a concurrency programming model, but this programming model is called asynchronous messaging concurrency model. And I think all the ICA, Erlang, and Go, all of the three programming paradigm have the same concurrency model. So I focus on compare with this one. Some traditional programming language we do not. I will not make comparison here because compare traditional ones is out of date in terms of distributed programming. For example, C, C++, or Java, or Python, all of them are focused on this concurrency model is from my point of view, it's a memory sharing based one. It's out of date. First, it's not, and this is the first drawback of traditional mainstream programming, concurrency programming. Mainstream programming model, there is a memory sharing based concurrency model. This is the one drawback because we have to spend a high effort, lot of effort on synchronous management. It's a difficult issue. Another thing is for this programming paradigm is threading is too difficult to manage, too tough. Threading is very tough to be used. If you have experience to program thread directory, you will know how tough it is. You have to manage how to create a thread, how to concurrency control the concurrency degree, how to assign task to threads, and how to, more important, you need to know how to monitor the status of the threads. You also need to manage the entire life cycle if you want to reuse those threads. Reusing thread is a very important issue because if thread is not reusable, you have to create thread, and frequently it consume a lot of computing resources. The performance should not be good. So because of the two major drawbacks, memory sharing and the thread is too tough, so it's almost no one will, at this time, if we're programming distributed system, thread is all become is in threading is it made invisible. So that means when developer used to use some more high-level programming languages, they don't need to care about threading. because of the two drawbacks, I can go and really make a lot of change on that. First, the memory sharing concurrency model is turned into message passing. Message passing. This is a big change. So that means memory sharing, message passing can provide developers with one advantage. That means developers do not need to the effort of synchronous management is minimized. Synchronous management issue effort is minimized. If we use a message passing approach, this approach to programming concurrency system, so synchronous messaging is one important popular exist in some new programming paradigm. So Alka, Go, and Erlang accept this using these techniques in their paradigm. And however, because they also believe threading is too tough to be programmed, so they make another change. They cover or conceal threading from developers. This is another big change. So when we can program with Alka, Go, and Erlang, threading is invisible, become invisible. Such that when you program with the Alka like languages, you do not need to care about thread. You just use their model, actor model. Actor model is actually a concurrency model. So you can send the messages synchronously between two different distributed nodes, remotely, even locally. You just the actors can interact with each other through asynchronous messaging, and you can also. But also the message, when the message is received, all the messages are processed concurrently. Messages are processed incoming messages are processed concurrently. So this concurrency processing of incoming message can be accomplished automatically. You don't need to care about how the threads are assigned to those tasks. You don't need to monitor the thread status. You don't need to know how to reuse these threads, how to collect the idle thread. You don't need to know about these things. That means when you're programming such a system, it saves you a lot of effort, right? So that's the major idea of Alka, Go, and Erlang. So I think for most of programmers, this approach must be good, right? You can see this code. This is the Alka code. You can see here. This is server side. You can regard this code as server side. Some message are received. The first one is disconnect. This is maybe like the message is when this disconnect message received, something will be performed. Disconnect something, right? Maybe the server is server disconnected. Another is disconnected. Maybe this is another kind of message. So after this message received, the server will perform something like stop. Stream. When a stream message is received, the server need to do something here. You can see the exclamation. This exclamation mark, that means the server can send a message from the server side to another actor. So this is the server. After the stream message is received, the server will send this message. The message may be called body to another distributed node. If one message is received, the message called the type of message is message. So after this message received, it will print this message at the local site. This is a simple code. This is just we do not need to explain the code in detail, but you can see here the server side is very simple, right? Very simple. You do not need to care about anything about the server programming. You think a server is difficult to be programmed. If you have experience to program a server, you need to know about the network programming. You need to know how to manage input output streaming using Java or any other programming languages. You also need to know serialization to transmit those messages. You also need to know how to schedule all the messages, and how to assign this message to all the threads, and all the threads should also be managed. It's very difficult to be programmed. However, you can see in Akka, the code become very simple. So Akka is this concurrency model is good if you program some distributed system with using Akka. But I just said just some. If you want to program this model is not universal. It only can be used in certain or specific computing environment, not just all the environment. I will make comparison using my between the make a comparison between this code with my code. My code is different from that. I think that I will explain that later. This code is a Go. This is a Golang code. Golang is also it also use actor model, although the code is a little bit different. But actually they're the same. For example, here is a button. This is also a message, right? This is also a message. I do not explain the Go language in detail, but here this is also, you can see here is a chain. Chain is a channel. Chain means channel. So the channel, there is a int. The message is int. It can button. So the message, after the message received, the server here will process something. You can see here is a Go runner. That means after the message is received, the server side will perform some concurrency processing the message. This is the message. The button is the message. So the server will process the incoming message concurrently. So although the code is a little bit different, yeah, this is the Akka. Here, this is the Golang, but their essence is the same. Both of them using the actor model. Actor model is the concurrency model. Both of them using asynchronous messaging to programming concurrency system, and both of them conceal or hidden the threading from developers. This is the two important feature of of the two programming paradigm. However, from my point of view, I I don't think this model is universe, or this model is can be generic, so generic. Generic means I mentioned many times in previous lectures. I think generic means we can use one programming model to do anything, to cover any specific scenarios over the internet. Internet is a complete distributed system. So is it possible we use this programming concurrency model in any scenarios? I don't think so. One issue is here. One problem. Here I can see the truth is that I'm sorry, no general purpose writing pool exists to adapt to sophisticated cases in any distributed computing environments. I think this is a common sense. No one can argue with me about this issue, right? It's for any distributed computing environment, not just distributed, any computing environment, because they're the running runtime is environment, and the specific concurrency mechanism, the concurrency requirements are different. The computing resources are different. Some resources may be rich, some resources may be limited. So there are different, so many different scenarios. It's impossible for us to use one omnipotent, no omnipotent thread pool exists. This is a common sense, right? So any thread pool are domain specific or environment specific. If this is a common sense, we need to investigate the specific computing environment case by case. Only if we can do that, we can design high quality concurrency system, because the thread pool is used to manage the threads, to provide high performance system, and at the same time save minimize the consumption of computing resources, right? So thread pool is one of the important techniques for concurrency programming. However, if the thread is not visible, how can we do that? If thread is not controlled by developers directly, it's impossible for us to do that, right? We cannot, the developers must miss this opportunity, lose this right to program the threads, to design the specific threads for one particular distributed computing environment, right? So I don't think this this technique, this approach to cover or to hide threading is a proper approach. Concurrency degree. One important, in some case, we need to know how to manage. We need to provide sufficient concurrency, right? We need to know how the concurrency degree. That means how many tasks are executed at a specific moment, or in one time slot, So we need to know about that. How many tasks are executed in 1 second or in 1 millisecond? So we need to know about that. However, if a thread is not visible, it means we cannot determine the concurrency degree. For example, if we need to design a map reduce system, that means there are 100 tasks, subtasks need to be assigned to 100 or 100 thread or 10 thread or 15 thread. So we can do that. We can provide accurate concurrency degree. We know the performance. However, if the thread is not visible, then we cannot define the concurrency. The performance is not controlled by developers if thread is not visible. If thread are invisible, right? So thread from what I have said here in this lecture, you may understand thread. Although thread is difficult to be programmed, but thread should be controlled by developers. So the second more important techniques in my system, I adopt the important approach, asynchronous messaging, because that very important. Memory sharing is not acceptable. So I use asynchronous messaging in my system. At same time, different from Akka and Go and Erlang, I also made threading visible. Developers can use thread directory. This is the code I program. I propose a new idea here, a new API. It's called player. I will explain the code in detail later. You can see here, player represent API that can control each thread by developer. But the developer can if you program with player, that means player is it can be called the remote handler of threads, handler of remote threads. On distributed nodes. The player can be explained in this way. So if you program with player, that means you are trying to control the remote thread directory. This is the client side. So this client, some player are created. Here is a create. Here is the parameter for player PC. The parameter is 10. That means this player contains 10 thread. PA and PB is just contain one. Is represent one remote API and one remote thread. This PC represent 10 remote threads. So after these threads, these players, the handlers of threads are created, you can assign some task to it through notification. Notification is just a kind of a message, right? This is the add internal notification. I will explain this example later. So this notification is sent to the from this PA thread to another to another node. This is another called slave K, and on slave K there is there's thread. So the PA can that means the two threads interact with each other, right? PA represent a remote thread. PB represent another remote thread. So using this API notify threads, this notification, this message is sent from this client to another client. So in another node, maybe not a client, another node, it called slave K. The slave K on the server of the slave K, there is a thread. It's this thread, we can get a thread K, and then this two number is added. So this thread will execute this task 1 plus 1. Then is that means PA can control this thread can interact with another thread, and both of them can work together. You can see here that this code is very simple. Although we can use thread, but this code is simple, right? We do not need to know how the threads are created, how to manage those threads, how to monitor the status of thread, how to detect whether the thread are busy or not, whether we need to collect the thread if it is idle enough. We don't need to know about the details. We just create something, right? Create a new thread and send a message to them. So it's very easy for developer to operate. That means although in grid-free, although threads are visible, but I have upgrade. These threads are not native threads from Java, because I created this system based on Java. So these threads are not native from Java, but it's changed to these grid-free threads are turned into messaging based threads. So it's easy for developers to control, to program, right? Here we can see the two threads can interact with the notification, and at the same time, the two threads can also interact with the request response. This is because we have seen in the previous slides, the message can be roughly classified as notification and request response. So you can see here thread player A, PA can read. That means send a request to another thread. Another thread will get a response, right? Because get a response after this request is sent, right? So here we got a response. So two threads can among these threads, they can interact with each other through notification and will request response. This is a simple code to present how to program thread in my system. So you can see here, grid-free is using asynchronous messaging to interact with each other. At the same time, the threads are visible, but different from traditional, not traditional, but from some existing popular techniques, Go or Golang, Akka, and Erlang. The threads become visible, and they are easy to be programmed, right? ELA program. So that means that is a more important difference between my system and the existing ones. If thread become visible, that means we can developers can program with threads to adapt to specific distributed computing environment. They can design, they can provide high accurate concurrency model. They can design high quality thread pool to support high quality distributed system. Thread should be visible, but this thread should not be native from the traditional system. We need to upgrade this traditional system, a traditional thread, to messaging based one. So that's very important comparison, right? This is the second one. Okay. Because today we have no time, so next time I will talk about another comparison between. This is the third fundamental techniques. I call it distributed patterns. That means we can, this is because last time in the previous lecture we talked three fundamental difference between my system and the existing one. So we'll talk about distributed patterns next time. This is the first lectures of this class. In the later class, we'll do not talk about so many words. We'll show some more. In the future classes, lectures we'll talk show a lot of code. I think code is more important. Someone said code is talk is cheap. Show me the code. So I will show you code later. Code is very, very important, right? So next in the future classes, you can see here, this is my platform. I programming with IDE. In the future classes, I will show you how to program with my programming model. But in this lecture, I gave you some here. This is wind, right? I call my project wind. So here you can see a lot of code here, a lot of code here. This is my program. This code is available on GitHub. You can download all the code. It's about 20,000 lines of code. And I think I'm still working on this code, and this project is very important, and it must be important progress in academia and the industry. Another one I want to show you is called free web. It's actually the origins of grid free. You can see the code, the large enough of code here, right? The amount of code is also huge, because I need to create upgrade the traditional World Wide Web. So this actually a project is I call the new World Wide Web. You can see the World Wide Web is a huge system. If we want to upgrade it, a lot of techniques should be improved. So you can see there are a lot of code here. The number of code more than 80,000 lines of code. It's also a huge project. Based on this programming, that's why I can invent this technique. So today time is up. So we'll talk about the next comparison about the design patterns. Design patterns is a very important foundation to support a new programming language. So we'll talk about this issue later. Okay, this is all for today. Thank you so much. We'll talk about that later. Thank you.